everyone. My name is Isabella. I am the chair of the design division at OSMED, and I would like to welcome all of you to this incredible discussion we're going to have today with our special guest, Isabella Delorenzo. A little bit about OSMED first. So OSMED is the Organization for Space Medicine, Engineering, and Design, and I'm here assisted by Michael Birchfield, who heads marketing at OSMED and makes everything that's happening today even possible. The mission at OSMED is to advance human space exploration by facilitating interdisciplinary cooperation, communication, and access to knowledge for the global community. So, when we have three disciplines like space medicine, space engineering, and space design that are doing incredible things in their individual silos, think of all the magic that can happen when there's a line of communication, common language, and common values between all of these disciplines. So that is what OSMED is about. So OSMED is a nonprofit organization, 501c3, based in the United States. If you want to learn more about the organization, you can go to osmed.org, osmed.org. You can find information about membership, about donation, about what we're doing. We're also publishing a lot of white papers having to do with that specific collaboration, and different types of research having to do with crew health performance, and everything related to humans, really. But my role here is to highlight an OSMED member every month. And so every month I choose between the many members that we have who are all individually incredible. And I want to give them a platform to talk about a little bit about where they come from, where they're going, what they're working on, and perhaps inspire all of you to get close to them and to integrate or to blossom even more in the space industry that we love so much. So I'm going to do a little introduction of Isabella. So I'm just going to read here. Isabella Delorenzo has a Bachelor of Science in Engineering Physics with a concentration on spacecraft instrumentation. Very impressive. She followed that with a master's in science in systems engineering with a concentration in engineering management. So climbing that ladder pretty quickly there. After an internship at Lockheed Martin Space, 4 internships with SpaceX on both Starship and Falcon programs, and graduation, she now works on the flight safety and mission assurance team at VAST as a reliability engineer. Welcome, Isabella.
Thank you. Thank you for having me. Super excited to be here.
Yeah. So Isabella, one way I like to introduce people is really to have them talk a little bit about where did you come from? Talk a little bit about your childhood, perhaps you had dreams of space and how you got to where you are today.
Yeah, sure. So working at VAST, I live in LA now, but I was born and raised in Florida, a super small town called St. Augustine in northeast part of Florida. And you could definitely see all of the rocket launches at the Cape from my backyard growing up. And that is, I feel like it's a stereotypical response, but that is part of what inspired me to pursue aerospace engineering. Combined with my love of astronomy as a kid, I figured why not put the two together, make things like rockets and space stations. So that's really where my passion came from. And then my bachelor's and master's, I got not too far away at Embry-Riddle in Daytona. And then now I'm here in LA.
That's fantastic. Did you come directly from Florida to Southern California, or did you go somewhere else in between?
Last year when I moved to LA, right before I came, I went with my parents and my boyfriend to Korea for 2 weeks. And that was my first international trip. It was super fun. Visited some of my mom's side of my family while we were there, toured museums, food markets. It was the best time.
That's wonderful. So throughout your academic career and your interests aligning with what you're doing for a living, have you encountered some mentors or people that, have inspired you to go a little bit farther than where you could have been alone?
Yeah, for sure. Through my 4 internships at SpaceX, my first one, I had a mentor, Dynamite, and he really pushed me to do the best in my work and learn so much from him, not only from the engineering side of things, but also how to interact with people, people of different disciplines, as OSMED is discussing. And on top of that, also my manager for 2 summers, Bryant, was a huge mentor to me. Really pushed my work in a lot of ways, and I think that's where I grew the most, is working under him.
That's wonderful. And I would like to remind everybody in the room, whether you are an experienced person in the space industry or someone who's just starting out or someone who's on the outside and just has curiosity for the space industry, go find those mentors. People are so incredibly generous with their knowledge, and you're going to cut, some months, some years out of that search for that role that's, is really going to fulfill your wildest dreams. So, and OSMED has a program, a mentorship program that can certainly help with that. So you talked a little bit about how, you grew up in this environment that was like very space forward. You had it like kind of in your face, and you studied, on a path that was like quite directed towards what you're doing today. But was there a moment in your academic or professional career that propelled you beyond your wildest dream, like one decision? And if you'd like to share that with us, that'd be great.
Yeah, I think so. Growing up, seeing the rocket launches at the Cape, I was young enough at the time where I started seeing SpaceX launches from the Cape. And then through my extracurricular activities at the time, meeting a lot of people talking about this company called SpaceX and learning more and more about what SpaceX did. And so that first internship with them and getting that internship offer kind of felt like the biggest step forward at the time for gaining experience in the industry, for really being where I wanted to be, like hands-on, working on a rocket program that I felt was going to take humans further into space. So that was one of the most exciting moments for sure.
And you came back 3 times after that.
Yeah.
And were the 4 internships in similar positions, or were you floating around different departments?
Yeah, I floated around a little. So the first one was with HLS Mission Management. And while working on their team, I got to dive a little into the Starship program and help them out with some little projects. So my next summer, I went to the Starship program under vehicle engineering. And then I did an additional summer there on the same team. And then my final summer was with Falcon Product Management.
Incredible.
So
Wow.
It gave a good overview to everything.
And so you're talking about summers. Were these internship done while you were a undergrad students and a graduate students before graduation?
Yeah, so these were all done in the summers after undergraduate years. So a bit of background on my academia there. I did my bachelor's and my master's in 5 years through the accelerated program that they offered. Super recommend it if any school offers that. It's a huge saver of time and money. But also it just allowed me, when I was, so excited about taking advanced courses and super specific topics, I got to take some master's classes sprinkled throughout my undergraduate, which propelled me forward on progress, but was also just super exciting to tackle. If you're doing general education like math and physics and things like that, and then you get to do something super specific one day. So that was a great time. But yeah, in between those years, after freshman through senior year, after each year in the summer, I did those SpaceX internships.
Incredible. Very, very impressive that you were able to do that so early in your academic career. I mean, look at you now. Talk about now. What are you working on right now? And I want to make a note here that please don't share any confidential information. I know it can be sensitive when you're working on something that's so fresh and new as what's going on with FAST. But what are you working on right now?
Yeah, I can definitely talk generally. So as you said before, I'm a reliability engineer on the flight safety and mission assurance team at FAST. And, um, all the efforts right now really focused, at least for me, on Haven One. So that's really exciting to have hands-on experience on something that's going to go into space and house people, but also really
Oh,
focusing, as the team name implies, on like safety, fulfilling the mission, crew safety, even down to like manufacturing safety. So it's a lot of reliability engineering in general. Really, is getting the design as it's being made or as it exists, and at least my job is seeing all of the failure modes, all the ways um, it can go wrong, calculating probabilities, ensuring fault tolerance, things like that. And it'll vary company to company on how they do it, what they analyze per team. But yeah, it's been really fun work. A great
that's
way to
really cool.
see a bunch of different systems within the vehicle.
Uh-huh. When we got on a call and prepared for this interview, you called yourself the person who is paid to be paranoid about. Yeah, could could you develop this a little bit? I love that. It was so catchy.
Yeah, for sure. That is, I feel like, a part of reliability engineering, really my job in general, and that's why I enjoy it so much. I feel like that's kind of woven into my personality already of um, taking something and trying to do it the most efficiently, and in doing that, kind of analyzing all the ways, all the paths that it can go, and kind of action plans for each path and things like that. So similarly, in something like safety engineering or reliability engineering, something along those lines, you usually do a job of like, okay, here's the design. How can the hardware fail? How likely is it to do that? How does that feed into mission safety and crew safety? So that whole roll up of things mathematically, but also just the basics of it too. So yeah.
Pretty incredible. So, for those who are new to the space industry, we're talking about VASTs and we're talking about Haven One. Could you give us a little bit of background about both of those things, just to like situate it a little bit? What are they about?
Yeah, and I'll preface this by saying the most accurate, most up to date info is on VASA's website, social media. They post on it like every week. So for pictures and more, I would definitely go there. But the general shtick is, the ISS has a limited lifespan. So there's a lot of companies, a lot of groups. There's some other competitors out there right now as well, making space stations to replace on it, and make sure we have that continued presence in space. So Haven One is just one of those solutions. And yeah.
Yeah, and am I right to call Haven One the first commercial space station? Could you
Yes.
say a little bit about what's so special about it compared to other options of space stations that are going to be eventually launched?
Yeah, I mean, I don't want to. I don't want to speak on the details of that too much. There are
Yeah.
definitely people at the company that are better experts in comparing all of those than me. Um, but I can say that I do admire, and part of why I joined this company is its dedication to crew safety and
Mhm.
how we look at humans in the design.
I know that the crew hasn't been announced for Haven One quite yet, but we know that there are like flight participants. So people who are not necessarily um, expected to act like professional astronauts. At least, maybe I'm wrong. And so, how does that impact the work that you do as a reliability engineer?
So yeah, like we don't know crew quite yet. So
Right.
really, in any space where you don't know who your crew is, you could be designing a dragging capsule, you could be designing some sort of vehicle. You're always trying to look at, and of course, this is something that OSMED has always talked about too, is how your design can adapt to whoever you're having in it. It could be a car or a bike. It isn't really constrained to just space vehicles, but you really want to look at how the design can adapt to differently abled people, how operations may adapt to personalities, or, for example, if you have a car, simple things like you can move the seat around because people might have different lengths on their legs and things like that. So that mindset really spans across all industries. So at least that's something I try to personally keep in mind. Working not only at VAST, but other things I've worked on.
Incredible. So I'm going to pivot a little bit. Back to you, the way you've approached your academic career, your professional career, and the type of job that you do today. Would you share with us what makes the work you do so special? If I had a line of like 10 different reliability engineer, like what is so special about you?
I feel like, at least I hope that I bring to the table a lot of different perspectives. I feel like my background is super diverse. My undergrad was in engineering physics, and that program is, as the name suggests, very much half and half engineering and physics. You come out an accredited engineer, but you have that physics background, which is super valuable. And then going into my master's, the systems engineering side, also focusing on things like system safety and human factors and life support systems. So I also have some of that weaved into things. And then a lot of like the projects and the teams that I worked on were for robotics and rocketry. And I did a project with a Baja car at some point. So I really try to bring all of those perspectives in, as well as my personal perspective. So coming from my mom's Korean, and my dad's family was Italian Irish. So coming from a deep cultural background, I try to bring different cultures to that too. My mom's family grew up in Hawaii, so bringing that culture. So I try to bring a lot of different disciplines, a lot of different cultures, and kind of blend all those perspectives in whatever job I do. So that's my goal, to make what I do special.
Incredible. So you obviously grew up with fantastic food. Is what I'm
hearing. For sure, yeah.
So let's segue a little bit to that last point and how it relates to OSMED. Let's rewind a little bit. Like, how did you learn about OSMED? What had attracted you to OSMED and push you to become a member?
Yeah, so actually I was introduced to OSMED by two wonderful individuals I work with at FAST, Dana and John. Great guys to work with, and they kept mentioning OSMED, this organization that they were a part of and helping with, and this wonderful conference that was coming up. So I looked more into OSMED, and I really liked the mission of making space for everybody. I think not just as a concept of, it might one day be nice to have or something, but as a concept of, we're at some point, it's going to be harder and harder to get people that is exactly the right stuff. And you don't want to limit space either, because let's say, and I'm talking low probability, but let's say you do have some interstellar type of thing, you need to get people in space one day, or there's more opportunities outside of this atmosphere that you want to spread to different people or different perspectives that bring value to a mission. You don't want to limit that to a certain type of people. And so I feel like design and research and everything is so lacking for this to happen. So I feel like OSMED is not only just an organization that, and you can kind of tell from the research that I did on it, like, it's not an organization that just sits there and talks about what we could do. And what I could tell from the conference is you take ideas and you really tackle them, find solutions to them, publish papers, talk to the right people, influence decisions. And I feel like that's somewhere where hopefully I can have a lot of impact and help myself. So, yeah.
Absolutely. Well, thank you for seeing us the way we want to be seen, and very active in all this. I've been involved with a few nonprofit organizations in the past, and nothing come close to OSMED in terms of how proactive, professional, warm, welcoming, and it doesn't matter what your background is, it doesn't matter how experienced you are or not. It's quite a membership. Like I can see it. And you can see it specifically at the Innovation Summit, which is where we met
Yes.
in person. Yes. I had quite a few people come to me and say, oh, I didn't know what I was walking into for this Innovation Summit. And all I could hear was people wanting to work with me and wanting to know more about what I had to offer. And this exchange between, designers freely talking to, flight surgeons and engineers was like incredible. So I'm glad that you're experiencing it this way. And we're always looking to find ways to amplify all of this. Is it like more one-on-ones? Like the mentorship program? Is it more having people contribute to white papers, which are like quite academic, but also expand to what's outside of OSMED. And we're also, we've been talking for quite some time about creating content that is that will welcome people outside the space industry, from people who work in business and other types of designs, or that have nothing to do with space, because we need all of these methodologies and all these brains and all these great intentions to come together to create a safer and more inclusive future of space, right? So very, very grateful to have you part of this. So let's move on to so kind of relate to OSMED and relate to the work that you do today. Like, how do you integrate into disciplinary collaboration? So you were talking earlier about you hearing about OSMED from Dana. I assume it's Dana Levin and John. Is it John Steller?
Yeah.
Yeah. Who are both, doctors and space medicine experts. How do you integrate interdisciplinary collaboration in the way you practice your work on a day-to-day basis? And how do you influence other people to want to do the same thing?
Yeah, so it's, I do work with Dana and John a good amount, as well as some other teams handling things like anything from, RF and communications to medical crew equipment, things like that. So definitely working with a wide range of people, not only engineers. And to have that collaboration, I think, is really important to bring, like I said, different perspectives to the table on how we're handling things, but also just in a general sense to learn from each other. In a way that will influence our work, but also we can carry throughout whatever else we do in our lives. For example, we might, just as a hobby, I keep up with, not even thinking about how to apply this to work, just as a hobby, I keep up with all the NASA stuff. I watch the press releases and things like that. So, like the recent NASA press conference they did on Crew 11 and bringing them home early, and the whole situation around that. They had their doctor there speak. And as an engineer, I'm very used to concrete definitions for different terms and a certain wording of things. So, hearing things like stable, I picture somebody who's in good health, but I don't know, as an engineer, somebody lacking a medical background, I don't know the exact definitions of that. So I might like text Dana and John and be like, hey, what does stable mean? And like my terms. So are there specific specific phrases surrounding that? Does that mean somebody's at a certain heart rate or blood pressure? Does that mean they don't have X, Y, and Z going on with them? So just learning and translating different medical jargon to what I understand, engineering jargon to what they understand, and collaborating on things like that, you are also increasing your understanding of how anybody outside of your industry and your experience will interpret different things you're working on and that they may someday interact with. So having that experience of translating things like that is super important as we think about this expansion of space for everybody.
That's awesome. It's funny that you bring up the word stable, because I'm sure that even in the medical field, different practices of medicine will define stable differently, right? Like an ER doctor versus, like Dana versus a OBGYN like John are going to see very different things depending on like the scenario and the health of the person. And same thing between, stability on Earth versus stability in an environment that's like conducive to being dangerous in space, right? Like, what do we consider stable? Last week I was in Washington D.C. at the NASA Moon to Mars architecture, and I was hanging out with Eric Hansenson and Jen Rockless, who are on the board of directors of OSMED, and they were trying to make a point, as NASA was giving us all the updates on that architecture. What actually happens when the human system is not working optimally, right? Like we make the assumption that we create the craft, we create the life support systems, all the systems that keep these people alive and well, but we always make the assumption that these people are just going to be fine doing the operations necessary to go forward. So I don't know if you have an opinion or a thought to share about that. Like, as an engineer, how do you see this kind of scenario, which is going to become more and more true as we go farther in the solar system?
Yeah, I think it's like, from an engineering perspective, you work on designs of anything really, and you're always looking for ways of, it could be designing a little hobby rocket. And I'm thinking in my design, okay, if, X and Y goes wrong, what is it going to look like? Am I prepared for it? Will the hardware withstand these conditions? Things like that. So I think from like my logic is, why don't we treat our crew and humans in whatever system we're building the same way? So if, and that could be a physical injury, any sort of mental health concerns. It could be differences in types of bodies that are using the hardware that you're building. So those differences and those things that may go awry in the situation, you have to design around as well.
Absolutely. I'm going to do a little interjection here. For those who have joined us a little bit later, welcome to this beautiful interview where we're learning so much about Isabella Delorenzo, who is a reliability engineer at VAST. We are here supported by OSMED, which is the Organization for Space Medicine, Engineering, and Design. And the mission here at OSMED is to advance human space exploration by facilitating interdisciplinary cooperation, communication, and access to knowledge for the global community. You can learn more on osmed.org. All right. This conversation is incredible. So in the audience, I would like for you to start collecting questions that you may have for Isabella. We're going to spend probably the last 15, 20 minutes of this hour going over those questions. We always have fantastic questions from the audience, so looking forward to that. We're talking about here a space station in Leo that you're working on, and we're coming back to the moon very soon. We're just like a couple of weeks away from Artemis 2 with the first woman going anywhere near the moon, and the first men of color to do so as well. So pretty incredible milestones happening. As a reliability engineer, space is incredibly dangerous. It's incredibly risky. How are you trained to manage when something goes wrong?
So at least in my current job description, I feel like I don't know that I'd consider, me being trained for if something goes wrong, live in a mission yet. That'd be a super cool thing to work on one day. But at least in my the type of work that I'm doing right now, I'm looking at ways to prevent that, at least from a hardware and design perspective. So, as a reliability engineer, and really we encourage all engineers to do this, but we are, at least I feel, I try to be the main gate of, okay, have we considered X, Y, Z, things like that. So really making a conscious list of many things you're looking for in hardware and a design. So as a reliability engineer, you deal with, let's say I'm designing something as simple as a door, right? And this door has 3 hinges and a little handle on the side. So, you can look at things like, what if one component on that fails, like the middle hinge and the little pin comes out or whatever? That door can still open and close. It's not going to hurt anybody. And those repercussions. You can think of how to design the pin from falling out, things like that. And you can go down to another component. Okay, the handle falls off. Well, it's really hard to open and close the door now. So just thinking through failures, how that propagates to the whole system, ways we've designed to prevent that, how it interacts with the environment. Are the hinges going to rust? And that's why it disintegrated and fell off, because of the type of air it's around. So yeah, just trying to keep in mind your environment, who's interacting with your hardware, and all the ways that a design can affect its usage and the people around it.
Nice. The way you described all of this feels very much like the way industrial designers, for example, are trained and work, right? Industrial designers, for those who don't know, in the audience, are the people who design the hardware side of things. So the physical parts coming together, assembled, and interacting with humans typically. And so one thing that's very big in the way we practice industrial design is we start with assumptions or expand our imagination on like scenarios. We come up with ideas, we build prototypes, and then we test them relentlessly. Would you say that your process is similar to that? Are you adding anything as an engineer that increases the level of reliability of the systems you're designing?
Yeah, I mean, it does depend on the situation for sure, but you always think of things to prevent a failure, like tweaking the design, though that magical phrase called, fault tolerance, where, you assume, these things may fail. So if you have, like the door again, you have 2 to 3 fault tolerance. Depends how many hinges you have on it. You can stack like 10 hinges on there and say like, okay, with 8 hinges gone, it'll probably still work. So you have that fault tolerance built in, things like that. So that's important to keep in mind there.
Like anything that we ship to space, volume and weight are really driving a lot of what's going on. And I know that with VAST and with any space station that's being built right now, I'm sure you guys are like weighing screws and removing as much volume as possible, but also finding the balance between creating an environment that is supportive of the life and support of this crew that's going to go up there. So how do you manage that balance?
Yeah, that's definitely a different team other than what I work on. But, I think it's a lot of teams working together to figure that out. You want to loop in the RAs, the responsible engineers, and because they really know their hardware the best. So you want to make sure they're always involved in whatever decisions you're making, and as well as people who might see things from the programmatic level, the reliability level. So making decisions like that, again, this is where also the multiple perspectives can come in. You want to make sure you have everybody's weigh in, everybody's sign off on something like that.
Awesome. Let's come back to OSMED. So OSMED, surprisingly, is less than 2 years old. That shocks a lot of people because we've been so productive collectively. Now that you're a member of it and you see how it works and you see the kind of benefit that you're getting from it, what do you aspire to see coming from OSMED in the next 2 to 5 years?
Yeah, I really, like you said, OSMED has done so much so far. It really did shock me. I remember going on the website and researching more about OSMED, and I was looking through the events. I was like, oh, they've had one conference and one is coming up, but where are the others? I feel like this has been around. Um, so yeah, there's been a lot of work done already. Like you said, mentioned earlier, white papers for different solutions for problems out there. Personally, I would love to be a part of more things like that. I know there was some sort of paper to come out of the first conference based on discussions had there. I feel like,
Yeah.
mhm.
Yeah.
I feel like we really had some great discussions with the most recent conference, which I attended, which was wonderful. I feel like there was a lot of discussions about all of the factors that could influence hardware design, which was super interesting. And I was glad to be a part of that. So I don't know, having these discussions and having an output like a white paper, presentation, video, whatever it may be, to influence those out there in the industry who are thinking about these problems day to day, and influencing what really happens in programs that are, just starting out or designing their hardware now. I would love to be a part of solving those problems.
Wonderful. Well, we're very, very happy to have you. And yes, you're always welcome to participate in anything you want, lead anything. That's one thing that I love about OSMED as well. It's like it really believes in, um, you know, um, the younger crop of space professionals like yourself, and we like to empower those people, right? Like it's not like the old experienced people would have been at NASA for 25 years who are the only one making decisions. There's a lot of proactivity that's happening from the younger people, and we love that. We love that dynamism. Please tell us how to do things, because we have a way of doing things that belongs to today and the past, and you have a vision about how it should become. Last question I would like to ask before we jump into Q&A. So I see that some people started posting some questions in the Q&A section. Please continue to do that. This is wonderful. So how do you see, if we're thinking about, the future, like commercial space station is going to be developed in LEO. We're going to come back to the moon to stay. And we're going to Mars and perhaps beyond in the next few decades. How do you see the influence of interdisciplinary collaboration in shaping the future of space?
I hope it'll be more prevalent than ever. Like I mentioned earlier, just today at work, working with different teams there and people like Dana and John and designers and different like crew equipment people. So there's a lot of different engineering disciplines that I work with because, not all engineering disciplines are alike either. There's so many people with so many different perspectives and things they have to think about day to day. So combining those roles with medicine, with designers, with even like marketing, communications, things like that. Those are all super important roles in whatever is next for the space industry. So I hope to see that more prevalently, more discussed, and just more, I don't want to say marketed, but like out there, I feel like when I say build a rocket or work at this company or that company, a lot of little kids think, oh, I'm going to have a hammer and a nail and I'm going to work on the rocket. And there are so many people and so many disciplines that can contribute to this industry, and opening those opportunities up for younger people to think about, for existing programs to integrate into what is already being done, I think is super important.
Wonderful. Well, thank you so much, Isabella. You have been like a incredible source of knowledge, yes, you are younger in your career, but you have already done so much, and it's so incredibly impressive. And we can't wait to have you participate even more to the OSMED mission. And yeah, and what I love about the way you talk as well, because I hang out with a lot of engineers as a designer, and sometimes there's a little bit of a attitude, I guess, that may show up, or this like intent on using very complex jargon, and you did none of that. You were so incredibly warm and welcoming in the way you think about things and the way you want to collaborate with others, and I truly appreciate that. That's incredible sign of leadership, and yeah, I can't wait to see what you build and ship.
Thank you.
Yeah.
Thank you for having me.
Yes. All right. Let's jump into questions. We have a few questions already. So I don't know how this works. This software is new to me. So live answering.
I think that's right. Yeah, I see the question.
Okay, wonderful. I will read it so everybody is aware of it. So Sarah, welcome Sarah, says, I'm also an aerospace engineer and did not take any medical bio or human factors courses for that degree. Wondering how do you bridge your engineering physics systems background with human interactive design and test needs?
Yeah, so I feel like there's multiple parts, so I'll kind of like dissect the question there a little bit. So yeah, I feel like as going through my engineering degree, there wasn't too many chances, even though I had that desire to take more classes in human factors and bio and things like that. There aren't too many chances to work those in. So I definitely feel the struggle there. Fortunately, I did have the opportunity in my master's to add some like human factors and life support systems courses. And learning from that was valuable, but also just realizing like there are so many resources out there to get that information. There's some good textbooks out there, and if I don't know if this is an OSMED member, but if you're on Slack, feel free to DM me. I have some textbook recommendations. But for like just learning about things like human factors methods or the history of life support systems on the ISS and how those work and what they've taken into consideration and things like analog astronaut missions that, are still being done and just what we have learned from those over time. So going out there and doing that research, I feel like has been super valuable. And just interacting with people within OSMED that have so much information to share. Yeah, so that's part of, I guess, how I am trying to absorb that knowledge from different sources and bridging like the engineering physics systems background with the human interactive design test needs. Yeah, I feel like at least one way specifically that I can talk about that I do that is throughout the engineering physics degree, my concentration was spacecraft instrumentation. So that's like a lot of sensors and things like that. And, doing many projects there through classes, research design, whatever. You're always thinking about the different environment that your sensors and hardware exist in. And I think taking that along with like the human factors, life support system knowledge, and combining that to, okay, you have this object and you're testing it in an engineering sense with its environment, but also thinking about it from a fact. And, there are some people way more expertise in human factors that are working on other things, human things relating to the design, but still thinking about how is the human interacting with your hardware? How could the human mess up interacting with your hardware? How do you keep them safe if the hardware fails? So almost thinking about the human involved here as a part of the environment, I feel like is super useful.
Awesome. Thank you so much, Isabella. So, as you were answering, I posted in the chat a link to a reading list that came from NGV SpearMed, which is basically this organization that helps train doctors and explorers on like extreme space medicine. So they just published that list. That might be very useful for you to tap into.
Yeah.
I wouldn't be surprised if it's like quite dense, but always good to know that it's there. Oh, hey, Eric, who published that list, is here.
I didn't mean to do that. When I logged in at the very beginning, it tried to put me on the stage, and it's like had my screen grayed out this whole time. All I've been doing is listening to you because I don't know why it tried to put me on the stage. But when you mentioned the SpearMed list, what I wanted to say was, Isabella, your comment on reading about ISS ecosystems and those sort of things, if you have some great references for doing that, for catching up and learning those things, send them to me because I maintain that list of SpearMed, and I would love to add in more in those things.
Perfect. Yeah, I have like one or two textbooks from some classes, so I'll send you the names later for sure.
Yeah.
Thanks,
it actually
Eric.
now opened up my option to return to the audience. So yeah, I'm still learning this software too.
Bye, Eric. All right, fantastic. All right, let's jump into question number 2. So I click on start live answer. Okay, so Carlin, welcome, Carlin, says, what issues tend to require the most negotiation when working with medical teams or life support specialists?
Yeah, so I don't want to give too much of a specific instance, just because like I don't want to go into too many specifics on the work at Vast or other companies, but I think I try to think of the work I do with other disciplines, whether that be medical or life support engineers or really anybody working on different things, less as a negotiation and more just trying to get to an understanding of where each is coming from, because going back to the interdisciplinary thing, even just among different engineers, like I may be in reliability, there may be somebody that comes from a heavy electrical background or structures background. And so I do know enough to talk with them, but the things that they're considering or the way that they're thinking may be a little different. So just trying to bridge that understanding, come to an understanding of what each person is concerned about, most likely, most of the time, the same exact thing that we're concerned about, and coming to a conclusion on how we're preventing that, testing for that, things like that.
Awesome. Thank you, Isabella. All right, next question from Elizabeth. Good to have you here, Elizabeth. Where do you think the biggest question marks or unknowns exist in designing the next generation of space stations? Long-term durability, evolving use case, ongoing physical and psychological health, etc. How do you try to solve all of these unknowns in your reliability work?
Yeah, so the first question I'll go through. So this is actually one of the reasons I joined OSMED. Is I wanted to be more involved in sort of the research and discussions of space medicine, things like that. Even though I don't have that medical background, I still wanted to try to be involved as much as possible. I think the thing that opened my eyes there is taking a life support systems class in my master's. I knew human factors. I knew how important it was. I knew that we need to do some more research, that people were still doing analogs to understand different factors. I knew that importance, but going through that class, I feel like I actually learned very specific things that we don't have answers for. So, and forgive me if I butcher any of these terms with the lack of medical knowledge, but things like, I think it's SANS, or basically people can go partially, completely blind in space for a reason that, as far as I know, we haven't really solved. We know probably radiation and things, but there's just so much research to be done there and tackle that if we're going into deeper space exploration. So that's just one thing. Or, we know that microgravity and radiation can have a huge effect on bone density and muscle mass. So working with designers, myself as an engineer, medical professionals, to try to think of more efficient ways, maybe less time-consuming ways to try to have astronauts maintain that bone density and muscle mass. So just little problems like that to try to solve and be more efficient, less time-consuming, things like that. Because at the end of the day, as you do space travel, you do want your crew, let's say, traveling to Mars or deeper one day, you do want them to have like a life. You want them to do fun things and research things they care about and spend time other than like exercising and worrying about their health and worrying about partial plan lists and things like that. So that's part of what drove me to OSMED in the first place. And then how do you try to solve for those unknowns in that reliability work? So I guess this is the long-winded answer of saying, I know I don't really deal with these sort of medical problems on a day-to-day basis. So that's why I joined OSMED, to try to help solve these problems that companies, government, otherwise may not be really interested in tackling now, because it's not really a concern for low Earth orbit. But if we're traveling for years in space or going farther to the moon for a long period of time or to Mars, this is really going to be a huge discussion, something that needs to be solved.
Wonderful. Thank you. All right. Next question is coming from Farhan. So Farhan Asif was our OSMED Member Highlights guest 2 episodes ago. I think it was either October or November. Please go to, I'm going to share a link of where all the episodes are. Please listen to what he had to say. It was incredible. All right. His question is, can you talk a bit about more about the experience at Embry-Riddle, to the university you attended? Did you have any international students in your cohort? I'm really curious about their aerospace human factor program. Would you love to connect and chat if later is better?
Yeah. Hi, Farhan. Farhan and I met at the conference and worked together in a group, and that was a really great time. But yeah, Embry-Riddle. Like I said, I wasn't in the human factors program, but they kind of let me work some classes into electives and customize the master's program to add some of those classes. And the professors in the human factors department, wonderful. So I highly recommend taking classes with them. Professor Doherty was my human factors professor for 2 classes, and he was amazing. As far as like international students, there are a ton of international students at Embry-Riddle from all different countries. Actually, my roommate for a year plus is an international student from Japan. She's wonderful, doing a lot of cool engineering and cybersecurity sort of research. But would love to connect and chat more later, but their program is very unique, I think, because Embry-Riddle is so aeronautical, aerospace minded. So anything that you do there, like human factors, will always have that background to it.
All right. Thank you so much. And we have one last question from Venkat. As a young engineer interested in human-centered design and spacecraft systems myself as well, what advice do you have for students to maximize their internship and entry-level roles to develop their skills in the field?
Awesome question. Yeah. So as far as developing, maximize the internship entry-level. Yeah. So, and you have the answers to half the question, but internships are super valuable. Highly recommend doing those, co-ops, any sort of programs that they offer to students. Just developing skills. I think taking on projects within, like if you're still in university, taking on projects there, taking on leadership positions there really shows when you're applying to internships and early roles and things like that, it shows them you have experience in ownership over a product. It doesn't, you're not saying, oh, I want to be a manager or anything, but you're saying that, hey, I did this leadership position. I was in charge of this thing. I collaborated because I was in charge of this thing. I collaborated with these people and I learned to own hardware and the whole design process. So things like that, I think, are super valuable to mention as far as like maximizing your time in your internship. I'd say definitely try to take on anything that excites you. These internships that you have are such valuable time because you only have like a few summers to fit these in. So go for companies that excite you, apply to random internships. The worst that these companies are going to say is like, no, try again. So apply for all the internships you can. When you get to those internships, I think don't be afraid to ask for different projects, different disciplines, and different companies handle this differently, but at least in my internships, if I found different disciplines or teams that I wanted to help out, kind of going to my manager and being like, hey, I saw this team over here has a little mini project I could help with. Do you mind if I spare like 2 hours a week in helping them with that? So just asking those questions and trying to get a wide breadth of experience while you're at this company, I think is super useful. And making all of those connections when you're at the company, you like the company, or even just the people that you're working with, add them on LinkedIn, check in with them, every 2 to 3 months, or comment on their posts. Just keep that connection going. Because let's say you want to work at that company in the future, you can reach out to them. They could put you in touch with people. If they move companies, but you're like, wow, they work for a really cool team now that I think I want to learn a lot from and go work there, it opens that avenue of connection that you already have. So yeah, I think those are great ways to maximize skills and your time while you're in that internship. But yeah, if you have any more questions, like I said, if you're in OSMED, feel free to reach out on Slack. Happy to DM about it.
Wonderful. All right. So this closes this incredible hour that we spent with you, Isabella. Thank you so much for sharing your wisdom, your experience, your generosity. For those who are OSMED members in the audience, for those who are not quite yet, please visit osmed.org. There's a lot of resources there. And, we're the kind of organization that really wants everybody to be given the space, the safe space to be active in building that beautiful future of human spaceflight. So please invite your friends, invite your colleagues in space or outside of space to be part of OSMED. We need more people, we need more voices, and we need more opinions to build that reliable and beautiful future of space together. Thank you so much. We are at the hour.
Great. Well, thank you for having me.